We have a line with gradient m and it passes through the point 0, minus 1. And in part 2 of the question, we are given that m is equal to 3. That means we are having a line where the gradient is a positive gradient. So m here is equal to 3 and it passes through the point 0, minus 1. Which means that the equation of this line is going to be y is equal to the gradient is 3x. And the y-intercept is equal to minus 1. So we have this. I'm going to call this equation number 1. Equation number 2 is going to be the equation that we have from the previous part of the question. So y is equal to 2x minus 4. This is equation number 2 and we are going to solve a pair of simultaneous equations here in order for us to determine the point of intersection between this line and the graph that we have from the previous part. So I'm going to sub equation number 1 into equation number 2. Which means that if I were to sub this in, what I have is 3x minus 1 is modulus of 2x minus 4. Which means that 2x minus 4 is going to be minus 3x minus 1, or 2x minus 4 is going to be equal to just positive 3x minus 1. If you were to be this, that means 2x minus 4 is minus 3x plus 1. I'll bring this over to the left hand side, 5x. Bring this over, this is equal to 5, that means x is equal to 1. And if I were to sub this back into equation number 1, I'll be able to get the value for y. Y is going to be 3 times 1 minus 1, y is equal to 2, which means that one of the possible points of intersection is going to be with coordinates of 1 and 2. Let's try to work on the other possible point of intersection. This, if I were to bring this over to 2x over to the right hand side, I will have an x. And minus 1, if I were to bring it over to the left hand side, it is going to be minus 3. And if I were to now sub this back into equation number 1, that means y is going to be equal to 3 times minus 3 minus 1, this is minus 10. And you know what? This minus 10 is not possible, because just imagine if I have a line that passes through the point 0, minus 1, probably somewhere over here, and it has a positive gradient, that means the intersection must always be one that has a y coordinates that is positive. So what I have here is a y coordinates of a point of intersection that is negative. That is why this part of the solution is going to be not possible.